chasing love.
When we're dealing with working with what? With second analytical geometry, right? Can you please talk to me? Right? So today we're going to deal with equations of tangents, right? So when you did equation geometry in grade 11, what did you learn about tangents? A tangent is always perpendicular to the radius or perpendicular to the diameter. Right? Right? Yes. So, what do we know about perpendicular lines? We know that if you are having two perpendicular lines, it means that the gradient of line 1 multiplied by the gradient of line 2, they should give us negative 1. This is what we learned in previous grades, right? So now we are dealing with what? With second analytical geometry, right? So we are trying to find the tangents of what? Of lines, right? The equation of tangents to the line, right? Yes. So let's take it to having this circle, right? So this is the circle that they gave us. This circle is saying x minus 2 squared, right? This change squared plus y plus 3. No. Leave them, they're working like that. Squared, right? Yeah. Is equals to 4, right? And they said that this line is a tangent at this point, 2 and minus 1. So this is the point of contact between the tangent and the circle. This is the line of contact, right? Contact point. So what do we do? So this is the equation of our circle, right? So I said if we are having the equation of the circle, we can find the center of the circle from this, right? Right? So what is the center of this circle? So it means that our center is 2 and negative 3. So this is our center of this circle, right? So what do we do if we are having the center of the circle and the point of intersection between the tangent and the circle? It means that we can calculate the gradient of the radius, right? So it means that our gradient of the radius will be equal to what? y2 minus y1 over x2 minus x1, which is the same as, if we can take this point as our 2 and this point as our 1, it means that our y2 will be negative 3 minus negative 1, right? All over 2 minus 2. That's correct. That's correct. Yeah. This thing is copied wrong. Yeah, it will give us error. So this one was copied wrong, right? Right? So let's just try to change maybe this point, right? So this point, let's make it 1, right? No, to make this work, let's just try to find another shape, okay? And let's just do another shape. This is this textbook. Okay, so let's try to have this circle and then we'll deal with a number of things that are working here, right? So having this circle that is saying x squared plus 3x plus y squared minus 4y, right, is equals to negative 5. And they said they're touching at point negative 1 and 3, right? So let's try to work on this, right? So it means that first thing first, we're going to try to find the center of this circle by completing the squares, right? So how do you complete the squares? You said you first check the coefficient of x and the coefficient of y. The coefficient of x is what? Is 3, right? And we multiply it by half and then we square it. So this becomes 3 over 2 squared, right? And what about the coefficient of y? The coefficient of y is what? Negative 4. We multiply by what? By half and then we square it. This is negative 2 and then squared, right? So what would be this equation of ours? This would be x squared plus 3x, and we add that coefficient on both sides, right? So we're adding plus what? 3 over 2 squared, right? And then plus y. Okay. So let's continue, right? So this gave us what here? 5 over 4, right? Equals to 5 over 4, right? So it means that our center is what? Negative 3 over 2 and what? And 2, right? So this is the point of the center, right? And the point of intersection is what? Negative 1 and 3. Right?
Yes.
Yes. Yes. Right? So it means that we are trying to find the gradient of the what? Of the radius, right? So it means that our gradient of the radius will go to what? y2 minus y1 over x2 minus x1. So this is our 1 point, this is our second point, right? So this is 3 minus 2, right? Over what? Negative 1 minus 3 over 2. Our gradient of the radius will become what? 2. Is it 2? Yeah. So this will give us 2, right? So the gradient of our radius is 2. So it means that now we can find the gradient of the what? Of the tangent. How? By saying gradient of the radius multiplied by the gradient of the tangent should be giving us negative 1. So what is the gradient of the radius? Is 2 multiplied by gradient of the tangent should give us negative 1. So it means that the gradient of the tangent is equal to what? Negative 1 over 2, right? Now we are having the what? The gradient of the tangent, right? When you are having the gradient of the tangent, you are also having the point of intersection. Can you see it? So this is the point on which, on the tangent, right? So we can now say, we can now say y minus y1 is equal to mx minus x1, right? So this would be y minus, what is our point? Is 3, right? Equals, what is our gradient? Negative 1 over 2 x minus 1, right? So what do we have? We have our y minus 3 equals to negative half x. This one will become positive, right? So this will be minus half. So y equals to negative half x, negative half plus that will give us plus 5 over 2. And this will be our equation of a tangent. Did you see that? So it means that whenever you are trying to find the equation of the tangent, first thing first, you find the gradient of the what? Of the radius, or the gradient of the tangent, yes. Which negative 3? This one? Yes, it went that side. Do you understand that? Which T? This is the gradient of the tangent. So we said the tangent is always perpendicular to the what? To the radius. So we use that fact and say gradient of the radius multiplied by the gradient of the tangent should give us negative 1. Do you understand that? So it means that after all we will find a point of intersection, right? Can you see that? This is the point where the gradient is meeting the what? The tangent is meeting the what? The radius. And you use that point to solve that. Right? So this is how we can find the what? Yeah, it works, but except for this time now we are not having. Oh yeah, but we can solve for C using that equation, right? So we can also say y is equal to mx plus c, right? So y is equal to what is our gradient? Negative half x plus c. Now we can substitute the points that we have to solve for c. Which points are we having? These are the points, right? So we say what? 3 is equal to negative half, and x is what? Negative 1 plus c, right? It will mean that our c will be equal to 3 minus half, which will give us 5 over 2. So equation will be y is equal to negative half x plus 5 over 2, which is the same thing as that. Yes.
This one is this coordinate. I don't know
which coordinate?
the one
For the radian, for the center. No. What is?
Only 3
So we just took this side. No matter how we solve the equation, right? Okay, so to answer your question, don't forget that our circle is more like this. Can you see? This is more like how our circle is, right? And this circle is having a center, right? Like glass. So having a center like this, right? And this tangent is the point where the circle and the circle are touching, right? So it can be something like this. So this point is the point this circle and this tangent are having, right? So our radius is like this, right? So this is perpendicular to that. So this is the point where the tangent is, right? And this radius, it is having this center now. As what? What are we having? Negative 1 and 3, right? And this point is what? The center is negative 3 over 2 and 2, right? And this is what? Negative 1 and 3. Right? Can you see that? So it means that this point is not on this tangent. So we cannot include this point. Can you see that? Can you see that? So this point is on what? On the tangent. That's why we use this point on it. Right? This point you can use it to find the what? The gradient of the radius. Can you see that? So we can use this point and this point to find the gradient of the radius. And from that we can use the what? The knowledge of saying these things are perpendicular. Right? Yes, there are many tangents on a circle, right? So we can find another tangent here. But it should touch the circle at only one point. There can be another tangent here. It touches the circle at 1 point. Another tangent here touching the circle at 1 point. So it is just like that, right? Right? So today I think we can finish only here on the tangents, right? So it means that the next time I'll just bring more complicated tangent questions, right, to solve it. And then from there we'll see what to do.